Hey everyone, so I'm going to do the review sheet for your first calculus test of the third quarter. It's on indefinite integration. Okay, so the first question says, evaluate the following definite integral. Keep the answers in pi, ln, or e if necessary. Okay, so for the first definite integral, what I'm going to do is I am going to integrate it. Well, I know that this piece right here, I can make x cubed over 3. And this piece right here is ln. The reason why that is ln is because you have a pattern of u prime over u. When you have a pattern of u prime over u, it equals ln of u. So in this case, u is x and du is 1 because the derivative of x is 1. So my integral is plus ln of x, because that's your u. I'm going to evaluate this from 1 to 3. When you evaluate a definite integral, you remember to do upper minus lower. So I'm first going to do upper. So 3 cubed over 3 plus ln of 3 minus the lower, which is 1 cubed over 3 plus ln of 1. So now I'm going to reduce this. Well, this piece right here, that's 27 over 3. 27 over 3 makes 9. And actually, I'm going to keep it as a fraction because maybe that'll help me in the end, because I noticed that this has a 1/3, which is the same denominator. Okay, but you can reduce it to 3 if you want. I'm going to leave it in terms of ln, because that's what the directions say, minus 1/3, and this is 0. ln of 1 is 0. And it's really good that I left this in a fraction form, because now what I can do is 27 over 3 minus 1 over 3. 27 over 3 minus 1 over 3, that gets you 26 over 3 plus ln of 3. And this is my final answer. The next question is the integral of 0 to pi over 2 of cosine dx. So the first thing I'm going to do is integrate cosine dx. The integral of cosine is positive sine, which is the opposite of the derivative. And I'm going to evaluate this from 0 to pi over 2. I'm going to do upper minus lower, so sine of pi over 2 minus sine of 0. Sine of pi over 2 is sine of 90 degrees, that's 1. Sine of 0 is 0. I know that because looking at the graph of sine, this is pi over 2. So that's clearly 1 up there. Alright, so my answer is 1. So now what I get is u to the 1/2. You're dividing by 1/2, but really we're going to flip that and make that 2 over 1. And I'm not going to forget the 2 on the outside here, and that I'm integrating this thing from 9 to 25. Just cleaning this up, I get 4 u to the 1/2, 25, and 9. And I'm going to do upper minus lower. So I have 4 times 25 to the 1/2 minus 4 times 9 to the 1/2. That's 4 times 5 minus 4 times 3. 4 times 5 is 20 minus 12, which gets you a value of 8. Okay, so my next integration is a fraction again. And usually when I see a fraction, I try my best to do some kind of u sub in here. So let me see if I can get the u sub. I'm going to make the denominator u because it's bigger. And again, like, I'm just trying this out. It might not work out, and I might have to do something else, but it's a good try. The derivative of that is 3x dx. And actually that's a really good sign, because if you look at this, that's 3x dx. So I can definitely do u sub. So that means my numerator u, well, du, and my denominator u. I need to change my bounds. Changing my bounds, I'm going to plug it into this. So it'll be 3 cubed plus 10. 3 cubed is 27. 27 plus 10 is 37. And 1 cubed plus 10, that's just 1 plus 10, which gets you 11. Now, this is actually a pretty nice integration because it's du over u, and that's ln. So this just becomes ln of u, evaluating it from 11 to 37, upper minus lower, so ln of 37 minus ln of 11, and that's my answer. I can get rid of the absolute value bars actually because they're positive, so we'll just make it like that. There's my answer. Next question is another integration. I have this in the denominator here. So what I'm going to do is I'm going to bring that up and make it the integral of 1 to 3 of x to the negative 3 dx. Okay, so now I'm going to integrate it by adding 1. And when I add 1 to this, I get x to the negative 2 over negative 2 from 1 to 3. I'm going to do upper minus lower. So upper minus lower, what I got going on is, well, actually, you know what I'm going to do is I'm going to rewrite this. So I'm going to make this 1 over negative 2x squared. That might make my life a little easier because now it's a positive exponent. Okay, so let's see, upper minus lower. So 1 over negative 2, 3 squared, minus the lower of 1 over negative 2, 1 squared. Okay, so I get 1 over negative 18, because that's 9, minus 1 over negative 2. These change to positive, and let me make this the same. So I'm going to multiply this by 9 and 9, so I get 1 over negative 18 plus 9 over 18. I'm going to put this negative sign up to make it negative 1 over 18. And what I end up getting is a nice value of 8 over 18. And that reduces to 4 and 9. So 4 over 9. Okay, so the next integration, I see a denominator of a monomial, and when I see that, usually I try to split it up. So if you split this up, you can make it underneath each piece. So what I mean by that is I'm going to make it x over x plus x to the fourth over x. Now you can only do that when it's a monomial in the denominator. And this will make it easier to integrate because that's 1 plus x cubed, and this is a regular integration. So 1 will integrate to x, and x cubed will integrate to x to the fourth over 4 from 0 to 4. Now I'm going to do my upper minus lower. So I have 4 plus 4 to the fourth over 4 minus 0 plus 0 to the fourth over 4. Well, this is just minus 0, so that's really done. 4 plus, well, 4 to the 4th is 64 over 4. 64 over 4 is just going to give you a value of 16. And then 4 plus 16 minus 0, that's a value of 20. The next question says, what is the average value of 3t squared plus 6t plus 2 over the integral of negative 2 is less than or equal to t is less than or equal to 2. This is just my interval from negative 2 to 2. Average value means I'm going to integrate. And this is my formula for average value, 1 over b minus a over a to b f of x dx. So in our case, it'll be 1 over, this is your a value, that's your b value. So it'll be 2 minus negative 2 from negative 2 to 2 of 3t squared plus 6t plus 2 dt. Be careful with your notation. I will take off if it's not correct. This is an integral with respect to t. These become 4, so 1 over 4. And I'm going to integrate this. So this becomes 3t cubed over 3 plus 6t squared over 2 plus 2t from negative 2 to 2. I'm going to simplify this. The 3's cancel. This becomes 1. That becomes 3. So rewriting this, I get 1/4 t cubed plus 3t squared plus 2t from negative 2 to 2. Alright. So now what I'm going to do is I'm going to do upper minus lower. So I have 1/4, that's on the outside. Upper is 2 cubed plus 3 times 2 squared plus 2 times 2 minus the lower of negative 2 cubed. Now notice I put that in parentheses because it's a negative, plus 3 times negative 2 squared plus 2 times negative 2. Okay, so now after typing that into my calculator, I get 1/4 times this value is going to give me 24, and this is minus 0. This whole piece is 0. And now what I have is 24 times 1/4. That's 24 divided by 4. That gives me a value of 6. That's my average value. Next question says evaluate. This is just a regular integral. You have e. If you remember the integral of e, it's itself divided by the value that's attached to the x. So if you remember, it's e to the kx over k. That's the integral of e. So kx over k is what I got here, plus x cubed over 3, evaluating from 0 to 3. Okay, so now I'm just going to plug in upper minus lower. I'm also going to try to keep this in terms of e, just because that's what the directions said at the start of this whole section. So I'm going to plug this in, and I will get e to the 0.05 times 3 over 0.5 plus 3 cubed over 3 minus e to the 0.5 times 0 over 0.5 plus 0 cubed over 3. So now what I'm going to do is I'm going to evaluate this. So it's kind of icky because this is 0.5 times 3. Well, that's e to the 3 over 2 over 1/2 really, plus 27 over 3 minus e to the 0 over 1/2 again. This just becomes 0, so I don't need that. Alright, so cleaning this up a bit, keep change flip. This becomes 2 e to the 3 over 2. This becomes 9. This becomes 1 over 1/2. Now 1 over 1/2 is 2, because keep change flip again. So I have 2 e to the 3 over 2 plus 7 as my answer. The next question says, find the values of c that satisfy the mean value theorem for integrals on negative 3 to 3 of f of x 9 minus x squared. So the values of c, well, you're going to do the mean value theorem again, but what you're going to do is set it equal to f of c and find c. So I'm going to do the integral of 3 minus negative 3 from negative 3 to 3 of 9 minus x squared dx and equal this to f of c, meaning that I'm going to replace c wherever cx. So 9 minus c squared. Okay, so this becomes 1 over 6. And what I'm going to do here is integrate this. So it would be 9x minus x cubed over 3 from negative 3 to 3. And I'm going to equal that to 9 minus c squared. Okay, so now what I got is 1, 6. I'm going to do upper minus lower. So be 9 times 3 minus 3 cubed over 3 minus the lower of 9 times negative 3 minus negative 3 cubed over negative 3. Oh, over positive 3, sorry. I'm going to get that value first, then I'll set it equal to this. Okay, so I have 1/6. This section here becomes 18 minus this section here becomes negative 18. These become positive. So I have 1/6 times 36, and that becomes 6. So I'm going to set that equal to 9 minus c squared, because that's what we're doing here. If you look up here, that's what we're setting it equal to. And I'm going to solve for c. So I'm going to subtract 9 here. This becomes negative 3 equals negative c squared divided by negative 1. This becomes 3 equals c squared. I'm going to take the square root. I get plus or minus the square root of 3 equals c. Now, just a side note, your interval is from negative 3 to 3, so you just have to make sure that this is in the interval of that. And the square root of 3 is 1.73, and negative 1.73 for the negative piece, so this is both of your answers. The next one says the volume V in liters of air in the lungs in a 5-second respiratory cycle is approximated by this model, where T is the time in seconds. Approximate the average volume of the air in your lungs during one cycle. One cycle is from 0 to 5 seconds. So that's your A to B, and when they say average, they mean average value theorem. So I'm going to do B minus A from A to B of f of x dx. So what I'm going to do is plug in everything. So I have the integral with 1 over 5 minus 0 on the outside, 0 to 5. I'm going to put this whole thing into there. So it's going to be 0.1729t plus 0.1522t squared minus 0.0374t cubed dt. And that's my whole inside. Okay, so now I have 1/5 on the outside. I'm going to integrate this thing. So 0.1729t squared over 2 plus 0.1522t cubed over 3 minus 0.0374t to the 4th over 4. I'm just going to make sure that I copied everything down correctly. It looks good, and now I'm just going to evaluate this thing from 0 to 5. So I have 1/5. I'm going to do the upper minus lower now. The only thing that I notice here is that when I do my lower bound, everything is going to become 0 because there's a variable next to everything. So I really don't need to even bother with the lower, so I'm just going to do the upper. So I'm going to have 0.1729 times 5 squared over 2 plus 0.15 5 cubed over 3 minus 0.0374 5 to the 4th over 4. Again, minus the lower bound is not necessary because everything becomes 0. All I did was plug this all into my calculator. Maybe doing it in steps might be useful so you don't make a mistake. But I ended up getting an average of 0.532 liters between the 0 to 5 seconds of the volume of air in the lungs. Alright, so I hope this helped. I'll see you guys soon. Study up.